Okay, hello. Hopefully the review went well. As I said in our post just now when I posted the review, I'm not able to yet go over the morning math. We're just waiting on one person. Sammy, thank you very much for doing it. Hasham, waiting on you, please, to do the morning math number 1. Today, I will be sending you guys a screenshot of the, because I know that you can see, thank you to Daisy for telling me this, you guys can tell that you got like 10 out of 13 or whatever, but you don't know actually which questions you got right or wrong. So I'm going to send you a screenshot of your like overall breakdown. I'll just have like a green for correct and then a red for incorrect. So when we're going over it, then you're going to be able to tell which questions you need to pay a little bit more attention to. And some of the questions will be repeated on the show What You Know next week. So it's important to make sure that you've kind of like wrapped your head around some of the little areas that you didn't do quite right so that you were able to show improvement by the unit final, which is the Show What You Know. And remember, you'll be able to use your notes. You can use a calculator, so it should hopefully go well for you. Okay, couple of things today. We're going on to a new thing today. We're going into something other than theoretical probability. We're going to the other one. First of all, though, thank you to these people who have submitted their work for the probability warm-up, okay, on Seesaw. So you guys have already kind of highlighted it. As long as you had it done, then you get a point. So merci beaucoup. Math test done. Okay, so today we are going into this experimental probability. Yesterday we did theoretical probability, which is what we expect to happen when we're doing an experiment, right? Like if you're rolling a dice, you would expect a 1 to happen 1 time out of 6, because that's how many ones there are on the dice. Now, experimental probability is different because this time you get to actually, who has a guess? I can hear you. Do the experiment. It's actually more fun. You actually get to do it and see what actually happens in real life. Okay, so this is the I can statement. Put today's date, June 10th. I can determine the experimental probability of outcomes in an experiment. So basically the same as yesterday, but it's rather than theoretical, it's now experimental probability. Okay, so most important thing, experimental probability is the likelihood that something occurs based on the results. Key. It's why it's bold and massive. The results of an actual experiment. So experimental probability is what actually happens. Okay? So when doing an experiment, this is what actually happens. Sometimes, the theoretical probability and the experimental probability will be the same. So, for example, when they're like, they're trying to figure out different cures for coronavirus. They would want the theoretical probability of it working to match the experimental probability. That's kind of what you hope for. But that's why we do the experiments, is okay, in theory, we've dreamed this up and it works in our lab, but then when we're applying it to real life, is that actually what happens? And this is something that like people who play lots of card games would be super keen on knowing. Like, okay, what are the odds that this is gonna happen? They probably would make their bets according to the theoretical probability in hopes that the experimental probability is the same. Or maybe they make their predictions based upon like the low chances of it actually happening in theory, but then it actually does happen in real life. So like anyone who buys a lottery ticket kind of deal, they would be hoping for a high experimental probability for it actually to happen. Okay, so this could be different or the same as theoretical probability. Honestly, it's chance. It kind of depends. But we will talk about how to get the experimental probability closer to the theoretical probability. We're going to do that tomorrow. Okay, so this is the formula. So this should match whatever you had from yesterday. So I would suggest flipping back a little bit and see how you made this pop out in your notes, what type of highlighter you use, try to make it kind of look the same, but maybe you want to use a different color of highlighter because it's not the same thing. Maybe you have one color-coded something, and then I would suggest doing a different color code for this one. Okay, so the formula for experimental probability is the number of times the outcome occurs. So this is how many times it actually occurred, how many times it actually happened. And then this bottom one is the number of times the experiment is conducted, okay? So how many times did it happen compared to how many times did you actually do the experiment? Okay, so here we go. We're gonna go through a few examples to make this more clear to you. So again, this you're gonna see down here, TP is theoretical probability, and then EP is experimental probability. Okay, so here's our first example. What is the theoretical probability of rolling a 5 on a 6-sided dice? Okay, well, theoretical probability from yesterday, right? You should know that. There's only 1 5 on a 6-sided dice, so the theoretical probability would be 1 over 6. Favorable outcomes over total outcomes. Okay, now who has a guess at what we're going to ask next? What is the experimental probability of rolling a 5 on a 6-sided dice? Okay, so this is kind of too bad because we're not in class, but if you guys have, a, I never know what it's gonna freeze on. Okay, so if you have a dice, you could do this. What you would do is you would roll the dice 6 times, and then you'd see, okay, how many times did a 5 pop up? So what can I do? I don't have anything that I can roll because I don't have a dice with me. But if you guys did, you could do it. Okay, I'm just gonna say that I'm gonna like roll my highlighter, and I guess there isn't 6 sides. That doesn't really work. Okay, I'm just gonna make it up. Okay, so say hypothetically, I rolled a 5 twice. That could happen, sure. And what would this be on the bottom? What would my denominator be? Well, it's number of times the experiment is conducted. How many times did I roll the dice? 6, okay? So in this hypothetical situation, I rolled 5, 2 out of 6 times in total, okay? All right, there you go. Now we're gonna do one more. Okay, hopefully that kind of makes sense as a bit of a beginning. Now, the next one we're gonna do is a coin experiment. So I would love for everybody to go get a coin. You get any kind of coin that you want to get. Okay, all right. So why don't you get that? And then we're gonna do this experiment. Okay, so pause me if you need to. Okay, so next, what is the experimental probability of flipping a heads? Or I kind of put it as like the teapot thing that's on the dirham, right? Okay, so we're gonna do a total of 6 flips. All right, so you need to first of all get your results. Okay, so we're gonna put your results first here with 1 coin. Then we're going to combine the results with a shoulder buddy, which would be here for a total of 2 coins. And then we would do it again with, whoops, and then we do it again with a group of 4, so everyone around you. Okay, now, this is really, we can't really do this because we're not all here. But, okay, if I was to flip my coin 6 times, okay, heads, tails, heads, heads, tails, heads. Okay, so I got 4 out of 6. I got 4 heads out of 6 rolls, okay? So I got 4, I didn't even put here, 4 heads. Okay, so my experimental probability was 4 out of 6 times. Okay, so now say that I was partners with Allie, and Allie got 3 heads. Okay, so now what would our combined theoretical probability be? Well, how many times did we conduct the experiment, both of us? Well, I did 6 and Allie did 6. So we would have 12 as number of times the experiment was conducted. And then, how many times did we get the favorable outcome of heads? Well, 4 plus 3 for us was 7. Okay, now say that we combined with, let's see. Say that we combined, say that we combined with Soyoon, and Soyoon got 1 head. And then maybe we combined with Rita. And Rita got 5 heads. Okay, so now what would our new experimental probability be? Well, it's going to be different than these ones, right? First of all, let's go to the denominator. How many times do we do this experiment? I did 6, Ali did 6, Soyun did 6, and Rita did 6. So 4 times 6 is 24. There were 24 times that the coin was flipped. And now we have to see how many favorable outcomes do we have. Well, 4 plus 3, 7, 8, 13. 13. That was our, I don't know, fictitious, I guess, experimental probability. So 13 out of 24. Okay, cool. So now this is your homework. Okay, you're going to see it's not going to be too bad today. Workbook. Questions, pages 100, 101. All of the questions. Oh, it's not due on Sunday. It's due tomorrow, Thursday. Okay. All of the questions, including stretch your thinking, which is this. Okay. So first of all right, you need to use this information. Saul, it was doing this like experiment with a spinner. Okay. So here are Saul's the theoretical probability of landing on any letter. Okay, so they say the theoretical probability first. When she spun it, or I guess he, I don't really know if it's a he or she, spun it 10 times. Okay, so landing on the letter A, let's see how many there are. 1, 2, 3, 4, 5. Okay, yeah, so 5 out of 10, or 1/2. All right, now, here are the actual results of Saul's, like, spinning. So A, they got 6 times. Ooh, more than what we would have expected. B, 1, C, 2, and then D, 1. So that's just, they're telling you, that's what they got for the experimental probability, okay? So again, here we go. We have the whole definition again, if you want to see it again. And then, okay. Okay, so now what Saul did is he combined the results of 10 experiments. So he did this 10 times, and then there were 9 friends, which he combined the results of, okay? So this is the cumulative, okay? So it's combined results, okay? You need to use this information for these questions, okay? So look at the table of Saul's individual results, which is this one, okay? What is the experimental probability of each of them? Now, look at the combined results, okay? It's going to ask you the same thing. What's the experimental probability of number of different options, okay? Hope that makes sense. Next, another spinner. Tatiana, here she goes. Here are her results, okay? How many times, okay? So you can just answer these questions. Okay, now, oh, they have a coin question here, okay? So you need to just do those ones as well based upon the results they already give you. Now, this is kind of the more fun part. You get to actually do some experimental probability yourself. So first you have to determine the theoretical probability from yesterday. Then you need to get a paper clip, okay? And yeah, so hopefully you can find a little paper clip or something that will work for you to make as a little spinner. And then you have to like put your pencil in like on the page, like at the center of it, and then put your pencil, you know, like into the bullseye kind of thing like this. And then you just like flick it and then spin it and then record your results. It says to do this 100 times. So that's going to be probably more time consuming than the rest of the homework put together. And then you get to answer your own questions. What was your actual experimental probability? So that's it for today. Okay, so hopefully we're learning the difference between the two of them. Okay, good work. See you soon.